Hi everybody, here's a quick little video to help you with your warm-up today. So one thing that'll definitely be on your test is what is in the element tile or square on the periodic table. And so we can find a lot of information just by the tile. So we start out looking here, and the first thing you have to do is what is the name of this atom? So you would go to your periodic table and you would look for the number 5. And so the name of this example atom is boron. The next question it asks for is the number of protons. And so you should remember that this is the atomic number. And the atomic number, it equals the number of protons in the nucleus. You should also remember that floating around in the nucleus with the protons are the neutrons. And if you remember from your reading in previous work, I don't know what just happened. You remember that neutrons have a little bit more mass than the protons do. So typically speaking, when we're talking about mass, we're going to give protons 1 atomic mass unit. This number right here, if you remember, is the atomic mass number. Or just the mass number. So you have to know the difference between the atomic number and the mass number. And what this mass number is the average of all the forms of boron. So that's why it's not an even number. Let me get rid of this thing that popped up. I thought I could get rid of it. Okay, we're back. And so the average of all the forms of boron that occur in nature. So that's why it's not an even number. So we know that the number of positives in the nucleus equals the number of negatives outside of the nucleus. So if we have 5 protons, we know that we're going to have 5 electrons. So that's the pretty easy part. Next is the number of neutrons. You actually have to do a little math to figure this out. If you're not paying attention to what you're doing, you would just put 5, 5, 5 for the answer. 5 protons, 5 neutrons, 5 electrons. But that's not the case. So what we have to do is consider if we had the equal number of protons and neutrons in the nucleus. So if we had 5 plus 5, that would give us the atomic mass number of 10. But if you notice, oh my goodness. If you notice that we have 10.811. So that means on average that there must be something else going on. So if we take this atomic mass number, 10.811, and subtract what we would expect to happen if the protons and neutrons were equal, that leaves us 0.881. So if they were equal, we'd have 5 neutrons, and then we have this left over. So plus 0.811 equals 5.811 atomic mass numbers. And so we would round that to the nearest whole number. So this would be 6. So instead of having 5 neutrons, boron actually has 6 neutrons. And so this is kind of where it gets kind of tricky in looking at your tile or your square. That if you just look and don't pay attention, you would write 555. You'd write 5 protons, 5 neutrons, and 5 electrons. But in actuality, we have 6 neutrons. So I hope this helps. Show your work as you go along. That'd be the easiest way for me to give you partial credit. And so this will be due at the end of the work.